Hi everyone, today I'm introducing a set of videos about security and I'll be addressing protocols like OAuth2, OpenID, SAML and similar protocols. They are really important because they are popular and used in, I think, almost any solution nowadays regarding IT and software architectures. So let's start with a real world problem that can be resolved using OAuth2. Imagine this, you want to use a third-party app to schedule tweets, meaning you have an application that wants to send something but needs authentication. For instance, if I want to send tweets, of course I need to authenticate on Twitter. And usually, if we don't think about protocols like OAuth2 or OpenID or similar ones, we have to provide a username and password. And since these applications, they work on our behalf, we have to put this username and password and trust the company or the server where our username and password will be stored. Maybe you can create a specific user for this, but again, it's a user password and we cannot limit the scope, let's say, of this application. If this application can access my tweet to send tweets, they can do everything else. Saying this as if tweet doesn't allow OAuth2, which is not true, but in a common scenario, or let's say before using OAuth2, that was the case. We have username and password, and or the application contained a set of permissions, or having a username or password, you can access whatever you want in that application. So in the past, that was how Twitter worked. Fortunately, today, most of the systems, they use OAuth2, and OAuth2 allow us to create a token, meaning that we don't have to provide a username or a password. We provide something that replaces that, and we can even constrain this to time and the set of permissions. And let's see how can we do this with OAuth2. So the problems before OAuth2, as I was saying, we had to share the username and password. So apps required full credentials, violating best practices. Apps store your credentials indefinitely, so there will be some file or configuration file, maybe encrypted, sometimes tables in databases. Maybe you can encrypt the password, but they are there. And I think now we hear less. I don't know if it's not happening or it's just because people don't want to talk it, but there were a lot of security breach in the past. Today we don't hear a lot about that, maybe because they have started using protocols like this one, OAuth, OpenID, things like that, where you can replace usernames and passwords with tokens. But that one of the problems is if you have a central place where all the users and passwords are there, if you can store that information, you can attack, you can try to decrypt, and even after you get those values, those usernames and passwords, the danger it's not accessing that system, because most of people use the same username and password in other systems. And if you know a little bit about the life of that person, you can try to use that username and password in other places. That was one of the risky things regarding to use usernames and passwords to access systems. So, and there is no way to limit what the app can do. So they have full access to your account, no scope control, meaning you cannot say, okay, you can access the system, but only this part of the system, because that system was not developed considering that. That's one of the issues. And changing your password was another nightmare, because sometimes imagine that you are in a company and you have this kind of policy to say every 30 days you have to change your password. And if you are using these passwords, and this applies to you as a user, but also the usernames and passwords that you create, even if they are used to be services, or they are not real people, but they are impersonating people to access the system. So those passwords will also expire. I remember to be in a project, I think 15 years ago, and I was using something like this, username and password, and I asked to the administration, to the admin guys, that today we call them DevOps, to say, please don't put a policy on this password, because if you expire this password, now the system cannot connect to the other one and the system start to fail. Just put a reminder, change it once in a while, but in a controlled way. And we have to document really well what are the users that are connecting between the service and things like that. It was a really, really difficult thing. And we, as we will see, we can resolve this using OAuth2, because it will resolve this problem. No delegation without full trust. You have to fully trust apps with your credentials and data. as we were saying. So now we have OAuth2, and when you start to use OAuth2, you start to understand it is a delegation protocol. It's not an authentication system. You can use OAuth2 authentication, but it's not its purpose. Its purpose is about delegation, to replace you as a person and your username and password by a token, something that identifies you, and this something will be scooped in time and in the permissions, which is great. So you can cancel it at any time, and you can still keep your username and password, which is the most important thing to access the systems that you want to access as a person. So the OAuth2 is a delegation protocol designed to fix this issue. So grant apps access to only what they need. It means that, for instance, if you are accessing, imagine that you have an application that prints pictures, and the pictures are in the cloud like Google, and you can give to a specific application that should be trusted by Google and say, okay, I will allow this application on my behalf, again the delegation, to access my photos, but only as read-only, and for 30 minutes or 1 hour or something similar. This you can't do with username and password, because if you provide your username and password, this client can access your photos, but also your email and other systems that Google uses. So you don't want that. You want something that can be of limited scope and constrain the access. And that's what this OAuth2 does. So it grants apps access to only what they need, and protect your login credentials, because you don't have to use them on this application. You still have to use username and password, but as a person, you will enter it manually. You don't keep this username and password in a file to be used by another application. This application will receive a token, not username and password, and we'll see in a moment how. And you can revoke access at any time without changing passwords. OAuth replace passwords with and access tokens, mean that you will be using a token that I will see in a further video, not this one. This one, it's only about what it is. My next video will go into much more detail, that have limited scope and duration. So that's what you gain by replacing your username by this token. So you have a token, and inside the token there is information about the scope, what can this application do inside the system that you are granting access, and for how many time. Okay, that's the purpose of the token. So let's start with the scopes. That's something that we talk here. Think as scopes like permissions, areas that you allow access. So what are scopes? Define what an application can access on our behalf, and it's you that will define. So you have a system and you have an API, and you can say that your API is something like read, write, create, and you can say, okay, there is scopes about, let's say, photos, and I accept read or write or create photos. And I can give to external applications, again, delegation on my behalf, a specific scope and say, okay, this application can email, read, and can also calendar write. You can group a set of them and provide in one token. You don't have to choose one. You can create a set of them. And the granularity of these scopes will be created by you. But it's quite common to see something like email and then read, write. I already saw something like email, read all, meaning sometimes read to a specific message, read all to all messages. But it depends on the creativity of who is designing the system. Of course, Google already provide these ones like email, calendar, and wrap. And you say, where will this be used? There are a lot of places and a lot to talk about it. But imagine now that you have an API, and this application needs to access those photos. So it will go through an API, and this API, it's also linked to Google. It's the API that Google provides to access the photos. So in this case, when it receives something like photos read, or maybe if a person is accessing the email, but let's continue with the photos read. And if you are trying to access an API that it's to create like a post of a photo and try to upload, this REST API will ask Google, or will look into your token and say, okay, what is the scope here? The scope, it's about photos read. So why is trying to create? I will forbid this access, even without knowing who is the person. But that token, let's say that ticket with that information, only allows to call APIs that accept this scope, that are open to this scope, to this permission or authorization if you want. That's why that OAuth2, it's a protocol about authorization and not about authentication. But again, it's also possible to implement authentication, but it's not the best approach. For that, usually use something like OpenID or other systems. But I already worked with projects where they were using OAuth2 for authentication, because with the tokens, if you have the token, it seems that you can access a system. So it doesn't prove who you are, but if you have that token, you can. It's like going to the movies. You buy a ticket, okay? But if you give to someone else, okay, that person can enter around the country. It's a kind of, it can still enter, but the system doesn't know who is this person. It doesn't validate the person, validates the ticket to enter on the cinema. And same applies on the OAuth2. It validates the token. If you have the token, you can access. It will not make sure that you are who you say you are, which is the basic of authentication. For that, you need another level, which is implemented by OpenID. But let's continue on our OAuth2. So this is some examples: email read, calendar. If, for instance, in Google, here in the GitHub, you have instance, for instance, repo. Again, you can see that here, use this symbol to separate. Here, use this one. There is no particular standard on that. You can write however you want. Google likes to use the dot. GitHub likes to use this symbol. You are not obligated to. You can put a word, say email_read. I also saw a lot of times that approach. So let's see some real use cases. So let's say photo service that I've been talking about. So photo printing service, and to access your Google Photos, again, before out, you have to enter a Google email password, and you don't know what happens with this. Imagine that you go to a company and you pay for them to print some of your photos. You say, okay, it's on the Google. So they have a system, say, okay, provide your username and password. I will not look to the screen while you write. Yeah, but the system is receiving that information, so they can store it and see it later. That's before the auth. After the auth, that will not be possible, because when you implement OAuth, the application first have to register on Google, the application, the printing service. Then it will have a client ID and the client secret. I will provide more details in future videos. For now, we have just to understand what OAuth is, but in this case, for you to understand the flow. So this application, the first thing that it does is it will put on the screen the login of Google. It will be the Google providing you the username and password, and you trust Google. You don't trust that the company or that is the printing service, but you trust Google. So you use username and password, and then the Google will validate and it will ask you, okay, this application is asking me for me to allow it to access your photos as a read-only. Do you accept? And you say yes. And then they will provide a token, let's say like a ticket to the movies. And then what will happen is this client application, every time he needs to display the photos, you have to choose which ones you want to print. It goes through the API of the Google and say, I have this ticket, or this token to be more accurate. I'm using the ticket as a kind of analogy. And this ticket provides information about the expiry time, who is this person, what are the scopes, and the scopes this says something like photo read, and say, okay, I can read photo. But if this application tries to do something more than this, that should be a different scope that it's not contemplated at a login time, it will forbid and say, okay, you cannot do that operation. You can only read or call APIs that accept that scope, which will be to read photos. So you are directed to Google, where you log in securely, you approve access to just your photos, and the app receives a token limited, and this is quite important, revocable. That's one of the advantages over using email and password. But you say, but I have to provide email and password. Yes, on the Google, not on the printing service company. And it's a completely different approach and more secure. Now that it's banking account, if you use PayPal or you have one of those personal finance systems where you want to manage the money that you receive, your expense, your incomes, you have to create nice charts. Again, it's the same concept. You can apply the same. You can allow this application in a limited way to access your real bank account, to say, you can only read my transactions, for instance. But the bank should implement, of course, as a client, the OAuth2 protocol. And meaning that your application will be a client for your bank, which means that your application is registered on the bank, and every time this application tries to read your transactions, we'll ask for the bank, I want to read these transactions, and the bank will say, okay, first let me ask the username and password for the real person. And the real person will have an interface, manually will introduce the username and password. And the bank will ask, are you sure that you want to access this application to do these operations? Yes. And then the application can do what you define it to be available for that application. For instance, I know PayPal does this because he already asked me once or twice this information, and I gave the permission just to read a few things. So again, it's safer. Was involved in OAuth. So these are 4 roles that you should know really, really well to understand this protocol. One is the resource owner. The name is already saying it's you. It's me as a person. It can be a service, but in this first video, let's check it's always a person, but it can be a system, okay? So let's see, it's a resource owner. It's the person that can provide username and password. It's the owner. It's the person that decides what will be allowed or not. It will, in my case, it will be me, and I have an account in Google, for instance. Now I have a client which will be our photo printing service from external company. And this external company registered before in Google as a client, said, I'm interested in your service because for sure I will have a lot of customers that they have photos stored in Google Drive, and I want to read them and printing them. And usually I only need the read permission, or in our case, the scope, and it registers on the Google. And during this registration, I will provide more details in the future. In case you are wondering, you will define addresses so the Google can redirect the token and other information to your website, and your website will receive this and can store the token that will receive. Behind the scenes, that's what's happened, but I will show you in a future video. All of this working will be creating a real client, maybe with GitHub or even Google by GitHub. It's quite simple to do it, and we'll see all this flow working. So the resource owner, it's a person. Then you have the client, which is the application that wants access, which will be our photo printing service. And then we have the authorization server, which will be Google in this case, which verifies the identity, will provide me a dialog box saying, okay, give me your username and password, and please accept or not the scopes that the client is asking for, in our case, photo read. And then, of course, you have the resource server, which is the server or the component that will receive requests from the client, in our case, to get pictures. Give me the list of pictures, give me the thumbnails of the pictures, download these pictures, and then I can print them. Okay, that's the 4 roles that exist in OAuth. So this is some details so we can summarize each one of the roles. So with the resource owner, the user wants the data, you or me, grants permission to an app to access a resource. Okay, grants permission when we authenticate. It's not before, it's when we need. Okay, never shares credentials with the app. We share credentials with Google because it's where we authenticate, but not with the app, the photo printing service. That will get a token from Google. We don't provide nothing to the client app. It's Google that will provide because we approve for Google. And why is this safe? Because we trust Google. If you don't trust Google, don't do it. So this will never work. So you accept OAuth when you trust in a specific entity, a specific server that you think it's safe, it's secure, and you can provide your credentials there. And you allow the system to access multiple places where you have some information, private data. When I say private data, as you as a person or your company or your projects, your microservices, and so on and so on. And the user can revoke access at any time. Usually the systems allows you to go there and say, these are your API keys if you want, or tokens, just cancel them, for instance. So let's say the user on the other side will be automatically somehow log out. If he tries to use the token will not be valid, so it cannot access again the resource, not the Google, but the resource or the API. And then the client, of course, you already understood what is the client. The client is the application interested in providing services on your behalf, photo printing services and things like that. So it redirects the user to the authorization server. Again, it's not the app that provides the login. it redirects to the authorization server. This, it's not authentication server. Check this name, authorization. It's not about authentication. But of course you have to authenticate when you reach authorization server, because first you have to prove that you are you, and then you can authorize things. Okay, that's why we can use this system somehow again as a kind of authentication system, but it's not the limitation. It's like a movie ticket. If you have the ticket, you can enter on the movies. Okay, use the return token to request resource from the API. That's the purpose of the token, of course, and cannot access anything unless explicitly granted by the user. So of course, if you are designing the system, you should be careful and should plan very well the scopes regarding your API and the scopes that you want to apply. Okay, example, photo album app requesting access to your pictures so I can print them. The authorization server, okay, this is where you log in, and it's the server that will provide the tokens and refresh tokens to the clients. Refresh token, usually when you provide, when authorization server provides a token to a client, usually it comes with a refresh token. It depends on the system. It's quite common in companies. In public, probably not so. It depends. The idea is that, imagine that you give, let's say, 30 minutes to token. After 30 minutes, it will expire. But you have a different token called refresh that you can use and ask for another token. It's a way for you to not require the person to be constantly log in to give you access every half an hour. The token can, this token, refresh token, can be used to create a different token. You can say, okay, but that's, so what is the purpose of the 30 minutes of 1 hour? That's, let's say, the risk time that you are providing in case there is a breach. Because if you detect a breach, you can cancel the token. And the most time that the attacker can gain, it's these 30 minutes on 1 hour. Because if you cancel, even the refresh token will not work. So it just stops. Okay, but let's see the refresh token as to avoid you to constantly doing a login. And of course, the research service, which is the most important one here. It's the service that provides the photos, emails, the repos if it's a GitHub. It's where the REST API exists. It's the place that the client connects with the token. It's to get the information that it needs. As usual APIs, Google APIs, Twitter API, Facebook Graph API, and so on and so on. So let's see a high-level diagram. This is not very detailed because it's not one flow. OAuth, I remember that at least 5 flows that you can apply in OAuth, simple OAuth, and I will be detailing them in my next video. But in this one, so we can recap the flow that we are talking about. So we have this user that clicks and connects to a service, let's say our photo printing service, and this client, which is already registered before, and I'll explain this in detail in my next video, will redirect to authorization server, which is Google. Google already contains some information about this client. For instance, addresses to send authorization codes and access tokens. So this will needs a kind of a server that will receive some information from authorization server. So usually you go to, let's say, let's see an hypothesis that you go to a shopping mall and I want to print some pictures. So I connect and the client says, okay, we want to print your photos, but of course we need your access to the Google. And of course what you do is that, okay, let me connect to Google. So we enter on this client to go to their application and say, I want to print some photos. And it will redirect you to the authorization server, which will be Google. You recognize that it's Google. It will appear, and then the Google, they ask you for a username and password. And then before moving on, it says, okay, this client ID that I know about because it was registered before, so you can trust somehow this client ID. And they are asking to read your photos from the Google Drive. Do you accept? And you say yes. Okay, so you grant permission, and now the authorization server will not talk to you again. It will just send an authorization code to the client. The client exchanges the code for a token. I will explain this in detail in the next video. And then it returns an access token. This is a token that contains inside the expiry, with sometimes it contains the email of the person, username, contains the scopes and other information. You can add the information that you want. There is some kind of a standard that you can force here, but you have some freedom to add your own attributes, but for sure scopes and expiry time will be here. And then the client will use this token now finally to the resource server that can connect to the Google Drive and display photos that you can choose. For instance, you click them and say, okay, just print them, and returns the protected resource, and the client can print and later deliver to you the photos already printed as an album. That's how OAuth, the main generic OAuth flow. By the way, this is one of the most important flows in OAuth, but there are usually some variants and other flows that you can use it. For instance, if you have a mobile application and sometimes you are not on a browser environment, but you can still apply OAuth flows, and that's why there are different flows regarding, or let's say, it depends of the security of the system that you have. If there is a person there, this flow works quite well. But sometimes you don't have, let's say if you have a single page application, you cannot store locally, for instance, something that the client requires, which is a secret. When you raise the authorization server, you don't want to keep that secret there. So there is a different flow where you don't have to use this kind of internal passwords that I'll explain later. And but I will explain where there are multiple flows and how to apply them in each use case. So in analogy, imagine that you have airline tickets. So OAuth2 it's like being issued a plane ticket with limited access. So you can board the plane, you are allowed to enter and take your assignment seat, first class, for instance, or tourist. It can be, let's say, your scope, even the specific place inside. It can be seen as a scope. Now you can use specific areas in the airport. You can access your cabin, again, scopes, overhead bin, and in-flight services, again. All of these are scopes. No cockpit or staff areas access, restricted zones are off limits unless explicitly permitted. Again, everything here, it's about zones. They don't care about who you are. They just want to see your ticket. That's the only thing. But of course, before you buy the ticket, you had to provide your passport or your identification card. So you authenticate in the kind of authorization server, and then they give you a token. And now you are the client, and you are accessing their resource. So in this case, you are a kind of a resource owner and client at the same time. And this ensures you have just enough access for your purpose. Yeah, you can take your trip and do everything that is necessary, no more, no less, reducing risk while enabling secure functionality. Okay, so let's do some mini exercise just to recap what we talk about. Let's identify the rules, see if you remember the purpose of each one. So an app wants to add events to your calendar. Imagine that it's Google. After a flight booking, you are creating a booking and you want to automatically add this event to your Google Calendar. Can you think about who is the client, who is the resource owner, what is the authorization server, and what's the resource server? If you want, pause for a moment, try it in your mind to understand. If you understand what is the purpose of each one, it should be easy for you to detect from this requirement what will be the purpose of each one of these roles. So I'll move on to the next slide. So answer, so the client, of course, it will be the flight booking app because it's the application that needs to connect to an API and that event. And of course, the resource owner, it's you or me who is doing the traveling. The authorization server, let's say it's Google Auth. That's why I said it can be Google, but it could be a different one. And the resource server, of course, it will be the Google Calendar API because the application needs to add events and usually it uses an API. But if you say different, but you understand that the resource server is who's receiving the request and the token from the client, it's correct. Anyway, it seems that you understood the concept of this role. So again, another quick quiz. So what problem does OAuth solve? It's one of the first things that I said when we start this video. Again, true or false, the client app should store user's password. If you remember what we start to say in the first slides, you understand the answers to this one. Name the 4 OAuth roles. It should be simple. You already answered for all of them. And what is a scope used for? Okay, again, if you want to pause and then continue, or you just go directly to the answers, I will provide them on the next slide. So let's see the answers. OAuth solves secure delegated access. It's about delegation or accessing on behalf of the resource owner. giving apps access without sharing credentials, meaning username and password. So we saw a way for an application to access a system, but it doesn't need username and password. It's false. The app should never store or handle user's password. The question 2 is the client should store the user's password. Third, name the 4 auth roles you should know by now: resource owner, client, authorization server, and resource server. And what is the scope used for? A scope defines a specific set of permissions the client is requesting access to. If you think differently, but you understood that it's about permissions and what are the limitations of the access, it's also right. So in summary, OAuth replaces insecure credential sharing with token-based delegated access. Again, replaces by sharing with token-based and delegated access. These are the words that identify OAuth2. Separates concerns, which is always a good or a great law, or I wouldn't say pattern, but it's a good practice. And across 4 rules for clarity and security. So if you understand the 4 rules, you understand their purpose, their really, I would say, scope, not in the OAuth way, but scope like requirements of each one, and supports scope-based permissioning, revocation, and least privilege access. Everything is good here. Okay. So thank you for watching this video. This is where kind of a theory video. Maybe the second one will also be before entering to great details. But the videos after these ones, after the introduction, we'll be developing something with this. I didn't decide yet. The language, Spring Boot, it's quite easy to implement an OAuth client and understood, but I will try to do some variation with the languages. So if you have any ideas or want to propose a specific language that you'd like to see to implement OAuth2, be free to ask me. Usually I can develop in several different languages. Don't come with something like Haskell or something. I know what it is, but I'm not proficient on that. But C#, Go, JavaScript, Python, C#, I already saw Kotlin, Java, and things like that. I'm comfortable with any of these classes. So I hope you like this video. I hope you learned something from it, and hope to see you in my next video. Thank you.